This section will be covering our next renewable energy source, wind power, which harnesses the movement of air to produce electricity. The generation of wind is a consequence of variations in atmospheric pressure worldwide, which in turn are primarily driven by the unequal distribution of solar heating across the Earth. Therefore, wind power can be regarded as an indirect form of solar energy. Similar to solar energy, the effectiveness of wind power generation dramatically varies depending on geographical locations. Diverse locations are characterized by disparities in wind speeds, influenced by factors such as latitude and the topography of the land. Numerous areas with exceptional wind power potential are also found above the ocean and therefore referred to as offshore wind farms. Many wind farms are located around mountainous regions, which have large changes in altitude and create natural air channels. For instance, the San Gorgonio Pass near Indio, California, experiences consistent high speed winds due to the channeling of airflow between Mount Gornio, shown in the image in the north, and Mount San Quinto in the south. This image is a close up of some of the wind turbines that can be seen from the I-10 corridor, but the San Gorgonio Pass Wind Farm boasts a massive collection of over 1,200 wind turbines and is capable of generating more than 600 megawatts of energy. Renewable energy sources have a long history of use by humanity spanning thousands of years, and wind energy is no exception to this pattern. In our previous discussion on solar energy, we highlighted the ingenious approach employed by Neolithic communities in China. Specifically, their dwellings were orientated to face south, a strategic choice that ensured exposure to the sun's rays at a lower angle during the cooler seasons of the year. This alignment allowed them to harness the sun's energy for heating and illumination. The image you see here is the earliest recording of a wind turbine, that of the Persian Panamones. Unlike our modern wind turbines that turn on a horizontal axis, these are a type of vertical axis wind turbine for a special reason, which we'll get into in a moment here, invented around 500 to 900 AD and used to mill grain. Here we have a schematic of the Persian Panamone. The schematic shows how the turbine would capture wind energy and convert it into rotational energy by the blades of the turbine, which would then transfer that energy through a shaft to a millstone below, and that millstone would rotate and crush the grain below. This example demonstrates how wind energy can be used to create mechanical forces. But how do modern wind turbines work? Modern wind turbines are designed to convert wind energy into electricity through the utilization of a generator. In the process, wind flows over the turbine blades, generating lift in a manner similar to how airplane wings work. The generated lift from the wind is responsible for causing the turbine blades to rotate. These rotating blades are connected to a drive shaft within the wind turbine structure. As the drive shaft turns, it operates an electric generator, and the operation of the electric generator results in the production of electricity. Wind turbine expansion has wind turbines that are experiencing significant growth in the United States, even in regions with lower wind potential. Like photovoltaic cells, wind turbines offer advantages when it comes to the environment. They produce no air or water pollution, and they don't require water for cooling. Um, as of 2022, wind energy ranks as the second largest renewable energy source in the United States, accounting for 29% of renewable energy production. Wind energy production exceeds that of solar energy by more than double, with a 14.2% lead. And this should come as no surprise. If we refer back to our levelized cost of energy generation we discussed in the last section, we can see that onshore wind production has emerged as one of or the most cost effective forms of utility scale energy generation in the United States. Wind turbines are also practical for small scale applications, such as generating electricity for remote off grid dwellings. A significant limitation of wind turbines is their reliance on wind conditions for power generation. Unlike conventional energy sources like coal, natural gas, and nuclear power, which provide a stable and consistent energy supply, wind turbines produce electricity intermittently, depending on wind availability. Ongoing development of technology for storing wind power is following a similar path to advancements in solar power storage, but at the moment is still quite expensive. Therefore, current electrical grid systems combine conventional energy sources that offer a consistent and reliable source of energy with those of renewable energy sources. Similar to solar power, the environmental impact of wind power is contingent on the physical placement of wind turbines. Wind turbines can pose a threat to birds and bats when collisions occur, particularly along migratory paths, which become particularly concerning when these species are threatened or endangered. Offshore wind turbine sites on lakes or in the ocean tend to have smaller environmental impacts compared to onshore turbines for this reason. Wind turbines also generate noise pollution, which has the potential to affect both human and animal populations. In many instances, the placement of wind turbines offshore helps to mitigate noise pollution. Additionally, the construction of wind farms has some small environmental impacts, including the development of service roads, the production of the turbines themselves, and the use of concrete for their foundations. However, when looking at the overall life cycle analysis, it becomes evident that wind turbines generate significantly more energy than the resources used for their manufacture and installation. That completes our discussion of wind power. In the next section, we will have a look at hydroelectric power.